Okay, so we're doing variable resistor sensor. Whenever you see this weird .211, it's the original Portenta library for the original Maker 100 course. This is the Maker 100 economical course. It's quite a bit cheaper. And you can get this from the library, so you can just go to File Examples, go to .211. If you click on this, you go to the actual code, and I'm just going to copy that code. And for some reason GitHub takes a while to copy it. And look at the information here. We've got ground to a resistor to AO, and 3v3 to the 2-wire sensor. We're doing any kind of sensor that has 2 wires to AO. If you look at your diagram, you've got ground there to AO, which is the same as DO on the Xiao, and 3v3 to AO. They're both going to the same thing. Now you can use a bunch of wires. I'm just bridging them, which is a little dangerous. You don't want to short out anything on your code. Anyway, let's fire it. Here's what you would do is you would go File New Sketch, and you would get rid of their template. You would paste the information, and you would check that your port is the right one. I don't know why the ESP doesn't label it properly. I've got the Xiao there, and I'm firing it onto the board. Also, after the port selected, you can select serial monitor, and it'll go there when it's all done. Let's have let's just see it in action first. So it's having some reading, but I take a light here, and let's position that properly. Move this over a little bit. And when we put the LED, notice the numbers go quite a bit higher. Okay. Maximum would be 1023 at this analog read resolution, which is 10. But this is fine. It's showing it's working. Let's just have a quick look at the connections. So ground to AO. So here we have ground is right, the second one. It's ground. It's just a resistor. It's bridging all the way over to AO. And then we have our photo diode, which is from 3v3, which is right there, over to AO. So they're both connected to AO, and that's the wiring connections. There's not really much to say. I took the camera off so I could do those. You would probably have it going from a resistor to a part on the board that you can work with, and then have it coming back, but I thought I would just bridge them. So that's it. If you change that resistor, these numbers will get higher or lower. And so your assignment is to figure out which resistance works best. With the code, you can change this, the numbers there, show you the ranges. So 16 would give you this huge range. Typically, it's not needed. Typically, 0 to 1,000 is a great range to work with the Arduino. Look at the setup. This is being commented out. That makes the serial monitor work. And all we're doing is we're printing a bunch of stuff and then putting a plus string so it prints out as a string, and we're analog reading AO. Delay of 1,000 is a little fast. You're welcome to change it to 3,000 or something. And that's the code.